Okay, so our integral then between 5 and t of f of t minus lambda d lambda turns out to be the integral from 5 to t of t minus lambda d lambda, and yeah, okay? And here's our function, t minus lambda. Okay, we can say y equals, if you want to use y, right? And it's got a slope of -1 and an x-intercept of t, simple linear function. Except now, of course, this is being restricted to the interval just from t minus 1 to t. Okay? So if t is between 0 and 5, I mean between 5 and 6, well, if we've got 5 here and 6 here, well, that's just a picture we have here. Okay? And we're restricting between 5 and 6. Why? Because our g of t function is 0 outside that interval and 1 inside the interval. We don't want to lose track of that. So we're just isolating what happens to this function on that one small interval. Okay? So, again, this gives us this area, same picture I had here. We want to reconcile that with this and make sure that this fits. Just to completely understand, well, to understand as best we can the way this function behaves. So that integral looks like it's safe because this area is the integral from 5 to 6 of the yellow function. Okay? So that is then and having trouble distinguishing a t from a lambda when I write it, but it's t lambda minus lambda squared over 2, the antiderivative of this function with respect to lambda. And that's t squared minus t squared over 2 minus 5 squared minus 5 squared over 2, just to write it this way so we keep track of what's happening with that 5. So this is 1/2 t squared. Okay.
Shouldn't that be 5t instead of 5 squared minus 5
I'm sorry?
squared? Wouldn't that be 5t instead of 5 squared minus 5 squared over 2?
Yeah, you're right.
No, I think you had that part right. Yeah, I think
Yeah.
just the first one. There you go.
Okay.
I think that'll do it.
Well, I'll go right this way. Minus 5t plus, I'll do 25 halves, just so we can maintain the connection with that number 5. Okay? And this should be the area of this little triangle. Okay? Now we could work out the area of that little triangle geometrically and for a given value of t and see what we get. Okay? And yeah, we've got a little time, maybe we can do that. Okay, well, so what you're seeing is, though, that the convolution takes whatever this function is, flips it, and then integrates it against whatever this function does. And in the specific case where this function is constant on a small interval, the integral is just going to be from the left-hand side of that integral to t. Okay? Now there's a lot more to it, but we want to understand then how this relates to the convolution of that future value function. Okay? And, well, we don't have time to draw that parallel, but when I assign the problems, you know, related to convolution, that's what we're going to kind of focus on. How is that a convolution? And then we get into some of the formal properties of the convolution integral and the Laplace transform of the convolution. Okay? Make sense? Somewhat?